Hello everyone, and welcome to another particular live webinar. I'm Mauro Servienti, Solution Architect in Particular Software, and today I'm joined by Andrea Saltarello, CEO and founder of Managed Designs. Andrea is a solution architect, trainer, and speaker, and he is also the co-author of Microsoft.NET Architecting Application for the Enterprise, published by Microsoft Press. Today we are going to discuss how to evolve your systems architecture leveraging CQRS principle and the intrinsic power of a service bus Sagas. As usual, if you have any question, please use the GoToWebinar question feature and we'll have a Q&A session at the end. So Andrea, up to you. Let's review the agenda.
Okay. Hello everybody. Let's just have a look at the agenda first. Okay. So just a couple of bullets. We start talking about what our workflow actually is, but we're going to be very brief at that, and we're just trying to start talking about CQRS as soon as we can, and we'll then start talking about Sagas as well, and we'll talk about technology because it's in the end, it's nearly all about the technology. That is what is going to empower us in order to implement Sagas and CQRS. And we'll try to have a look at quite a lot of code, indeed, because actually we are developers and code is what we're expected to deliver. And then we'll end with our Q&A session. Okay, so let's talk about workflows first, and I'm kind of lazy, so what I did is to just copy and paste the workflow definition you can find on Wikipedia, and I think nothing complex here, nothing strange, nothing new, so we're just talking about tasks, steps that have to be executed, coordinated, and pertaining to a particular business or process. And just, let's say, the sequence of operation, okay? But what I try to do is to just focus on a simple workflow. And I know that this is the ugliest chart you've ever seen in your old life, but I just tried to use PowerPoint as a modeling tool, and I kind of understood why it isn't sold as a modeling tool. But I just tried to show which steps and events, actions are pertaining to the process of invoicing. So it all starts with issuing an invoice, because we just want to be paid for something we've done for a customer, and then we're going to ship the invoice, and we're going to kind of wait, just hoping that the customer is going to pay us. And sometimes that's what happens. Other times, unfortunately, that's not going to happen at all. And so an invoice is going to expire, and it's going to expire still being unpaid. And what we're probably going to do is to notify our customer and then wait more time, and then wait and maybe notify the customer again, and sooner or later we're going to start a credit collection process, which is another process, okay, but it is started just because our invoice is still both expired and unpaid, okay? That's the process we're going to focus on. And more precisely, we're going to focus on the very last steps. Okay, so the ones that starts from the very moment in which an invoice expires. Okay, and that's it. Okay, it all starts with a user, either a user or a scheduler, firing code similar or expected to be similar to the one shown in this slide, because we have maybe we might have a user clicking a button, and the button is going to extract all expired and unpaid invoices from the database, and this is a standard query, I think. And then we're going to iterate across all the set of the expired invoices, and we're going to notify our customers about each and every one expired and still unpaid invoice. Okay. The point about this code is that it is, I think, quite. I define it as being quite noisy. Why noisy? Noisy because a web class does not speak a language close to the business one. A query speaks a language that is close to the database language. So we're going to have a couple of ands and ors that are going to test column values in terms of is his invoice paid, is invoice still unpaid, has invoice expired or not. And then we're going to iterate a lot of code actually, and very little in terms of business, of spoken business. Okay, and what we're going to try to do during this webinar is to have a look at how we can make our code more self-explaining, more manageable, and more explicit in terms of speaking about the business is going to support, the code is going to support. Okay, and that's where CQRS kicks in. Okay, this is, I think, the simplest chart diagram we can draw in order to explain what CQRS actually is. And it is very similar to a chart you can find on Greg Young's own website. But just because, you know, CQRS, it is actually a simple pattern. It is all about having different stacks for querying our system and to ask our system to perform some action that might sort of alter the system state, such as, you know, modifying some NAD attributes. Okay, and we're trying to compare this diagram tries to compare a CQRS architecture with our usual layered ones, such as the usual domain model architectures that DDD practitioners have been implementing for, I think, 10 years now, more than 10 years now. Okay, so it's all about having different stacks for reading, querying the system, and performing tasks. This architecture is inspired by a software architecture principle, software engineering principle stated back in the 80s by Bertrand Meyer, which is a very renowned developer, architecture. Is the author of the IFL language, which is an object-oriented language sporting a couple of nice features, such as a very peculiar implementation of the multiple inheritance. feature. And the point about CQRS, Common Query Separation, and then CQRS, Common Query Responsibility Segregation, is all about having code units being either queries or commands, so tasks. And the point, the very difference between CQRS and CQRS is the granularity. That's because where CQRS thinks in terms of code units, so I'd say functions, CQRS thinks on an object level. So we're going to have classes that are going to either be commands or queries. But the point is that I don't know, I think you're going to agree with me, but we face a lot of difficulties, we had a lot of troubles trying to model, to define the perfect model, because what we just tried was to describe reality. But models are not about describing reality. Models, software models are about being effective at solving specific problems. And what CQRS and CQRS tell us is that the very difficult about trying to have a perfect model is that a single model capable of describing information and to perform tasks is quite impossible to achieve, to define. And the very point is to have different models. Let's just try to have a look at how we can achieve such a thing. So, a single slide, okay, with a single line of code that both extract data and perform a task, okay? So, we're going to talk to a database and ask it to just produce the list of all outgoing invoices, and we're going to only select the one pertaining to a specific business unit, and then we're going to apply another filter in order to only get the expired ones, and then we're going to state using the select clause which is the part of the data model we're interested in, and then we're going to try to use all the cores, CPU cores we paid for, and then we just try to notify our customers, okay? So, a single yet seemingly effective line of code using two different models. Let's just try to have a look at how we can implement such line of code in Visual Studio. I'm going to use, during this webinar, I'm going to use an open source project you can download on Codeplex. You can find it at I'm very sorry. You won't believe it. I just completely forgot the URL. So I beg your pardon, and that's it. Okay. So you're going to be able to download the code, to compile and execute the code. Okay. This Codeplex open source license, you can clone the repo, you can fork the repo. It is a standard Git repo. Do whatever you like with this code. And what we've done here is to just define different models for querying the database, plain, standard, boring, any framework bucket data model, I'd say. And this is the one we're going to use to read information. The read models also support a couple of custom link operators, just to be able to write a fluent query, a query which uses the language very near to the business language. That's why we were able to write this code. Okay. Oh, I kind of spoiled myself. Okay. So this is code pertaining to the read model, whereas this is code pertaining to the command stack. In this scenario, notify customer is a very simple function taking both an invoice number and a customer ID and using them to notify a customer about an expired invoice. Okay, so let's just think about this line of code a bit. It is quite easy to read, okay? It is quite close to the ubiquitous language, and this is something DDD practitioners are going to appreciate a lot, I think. But we have some drawbacks as well. This is synchronous code. That means that, okay, we took advantage of records available, but each notification is going to be a synchronous one, and it kind of impacts our scalability. And we also have the need of a human, of a user, or a scheduling engine in order to fire this notification. Okay, it's a user clicking a button or a scheduler executing the shown code every once in a while. And what we're going to do now is to work about these drawbacks in order to have a look whether we can overcome them or not. Okay, so let's try to stick to a different strategy, okay, when it comes to commands. So let's have a system architected in a way that our application, which by the way is a web application. This is the application you're going to use, MERP, okay? So accountancy, issue an invoice, customer code, date of issue, amount, taxes, total price, blah, 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 blah. A very basic registry in order to register people and companies and later use them as either customers or suppliers. Okay, so let's try a different strategy. A strategy where we have an application asking the system to perform something and have this execution being performed asynchronously. That means we're going to have our front-end application, the ASP.NET one, and the back-end engine mediated by some tool or device allowing them to communicate. Okay, we will refer to this tool calling it a mediator. Okay, and we're going to talk later about what a mediator actually is and how can it can be implemented in such an architecture. Okay, so application just sends commands to the system, and the mediator is going to dispatch commands to workflow managers. Okay, and we're going to refer to workflow managers in this webinar under the name of Sagas. Okay, and we're later going to talk about how precise this definition is. Okay, but let's just pretend for the moment that this is a perfect definition. So we have commands dispatched to workflow managers in order to have them executing commands and state success or failure accordingly. And we're also going to have handlers in order to update databases accordingly. Okay. In the provided application, we are going to use different databases for storing data and to also support the normalized database in order to support the read model. Okay. So we're going to have all these commands and responses dispatched by our Mediator. Okay. Enter Mediator, the very same user story, but we're now going to implement it by means of a Mediator. The very difference is that the for all clause is different because we're not going to actually call a function acting as a command anymore. We're going instead to actually model commands under the form of objects, as objects, and then have this object thrown at the Mediator, which in the end is going to dispatch the commands to workflow managers. Okay, so let's just have a look at how we could implement such commands. In this implementation style, what commands actually are just plain objects. Plain immutable objects, I'd say. And so we have a constructor. Commands are self-contained as well. We're not going to use a customer class, but just a customer info, I'd say DTOs defined inside the command. We're just using nested classes in order to state in a very clear way that this data structure is only pertaining to the containing commands. Okay? And so we're going to have an application just creating a command instance and then sending this very instance, these commands, to the Mediator. What's the effect of this implementation style? Okay, it is still both easy to read and close to the Mediator's language, and provided the Mediator is capable of doing that, we're going to have an asynchronous architecture where one in which the application just asks the Mediator to dispatch something that is going to eventually be executed. But we still have one drawback. We still have the need for either a scheduling engine or human actually firing this task. Okay, and that's something we really want to avoid. Okay, so let's first try to talk about the Mediator bit. Okay, because we're going to need some kind of tool in order to perform as a Mediator, and we have a couple of viable options, of feasible options, and the most used ones are queues, such as Microsoft owns message queue, Windows message queue, or we have service buses, such as and service bus of particular software stream. Okay, both are viable options. Okay, because both are capable of being asynchronously delivering durable messages. Durable means that should the mediator fail for some reason, after a reboot or a mediator restart, we're going to have our messages still being there, waiting to be delivered. Okay, we're not going to lose messages. That's really something we don't want, to lose messages. But still, buses are typically a preferable choice because of a couple of advanced capabilities they support, and I think I'm going to show you a bunch of them later, and Mauro and Sean are going to show you a couple more as well. Okay, so let's just say that during this webinar we're going to use a bus. Okay. And that's where Sagas kick in. You know, I'm kind of a lazy guy. That's something I already told you. So I wanted to write down a nice definition telling what a saga actually is, and what I ended up doing was to just copy and paste a definition stated by Allende. That's because Allende is quite a renowned developer in the .NET community. This is a citation coming from Allende's blog. And you can follow the link and have a look at the complete post. And having a look at the complete post, you'll understand that, you know, there's a difference between sagas and workflow managers, but sagas are quite effective at pretending to be workflow managers. And I think Mauro really wants to give us a word about this very topic.
Yes, thank you, Andrea. We had an interesting question that was asked offline before the webinar. Strictly related to the fact that in the webinar title we use the workflow word instead of the saga one. And the question was related to the fact that there is a difference between what a saga is and what a workflow is from the architectural point of view. And yes, there's a difference. So let me just give you a brief overview of what's the main differences between a saga and a workflow. From the architectural point of view. Let's say that the N-Service Bus Saga specifically are an implementation of what we can call the process manager pattern that often takes one of two main forms when implemented. One can be the observer one or the controller one. Let's say that the main difference is that when a saga is implemented as an observer, and we used to say that from our point of view, that's our favorite way of implementing the saga. Messages are received by the saga itself as events. So a saga interacts with the system through events only. And the saga has no control at all, and that's a good thing from our point of view, over the order in which messages are received by the saga itself. Being events, they are eventually consistent, and the saga is capable of handling them out of order. So the order is not important at all from the saga perspective. When a saga is implemented as a controller, the process manager pattern, when implemented as a controller, we have a controller that issues commands and expect replies from handlers doing the real work. So basically the controller issues a command and expects someone else to react to the command, replying back when the thing is done. Let's say as an example that we have an e-commerce management system. At a certain point in time we need to charge the user credit card. Implementing a Saga as a controller, we are going to send out a command saying charge user credit card with details about the charge that should be done, and we expect the controller expects to receive back a message or an event saying user credit card charged. And only when the event or the message, the reply is received, the controller moves on to the next step. Meaning that in this implementation type, the controller has full control over the message processing order sequence. There's obviously pros and cons in both approaches, but Saga are designed to implement process manager patterns. On the other hand, what a workflow is that a workflow contains both the process manager implementation, so the orchestrator side of things, and the business activities as well. So basically a workflow is both a process manager implemented mainly as a controller, so I have full control over the processing sequence, and at the same time is itself the actor that is executing the business logic. Nothing is preventing us to implement a workflow using a Saga. So basically in most of the Saga samples and all the samples that we are going to basically show today as the first touch with Saga will be mixing both the process management and the business side of things in order to keep the sample simple. But the main difference between a Saga and the workflow is that the workflow has two responsibilities, and looking at the single responsibility principle, maybe it's a smell, as the responsibility of managing the process and managing the business activities. Whether on the contrary, a Saga has only the responsibility to manage the process. The managing the business activity should be done by different endpoints, services, or components in the system that can be deployed as different entities or different endpoint instances. Back to you, Andrea. Thank you.
Okay. So let's go back to our slide deck and let's talk about Sagas a bit. Okay? And we're basically going to have the code talking. So let's have a look at a simple Saga pretending to be a real invoicing workflow manager. What we already had a look at is that we're going to implement every command pertaining to invoice management as plain object, such as issue invoice commands or associate invoice to job order. That's something we do want to do because we want to use invoices, costs, revenues for evaluating a project or job order balance later on in time. Okay. So we will end up having quite a lot of commands, one for each task our application is capable to perform. And I just tried to copy the Saga in Notepad, so to get rid of toolbars and chromes and have more space for the code. So I am a Saga, I am the outgoing invoice Saga, and I am a Saga. Saga base class is a base type that your boss is definitely going to provide you. Okay, and I am started by this command, and I also manage this command, and in the end I'm going to have an I handle messages interface implementation per each command I'm going to manage by means of the Saga. Okay, and sooner or later I'm going to receive an issue invoice command sent to the Mediator by the application. We already had a look at this simple line of code. Okay, this is code called by the controller, the MVC controller. Okay, we're going to ask a factory to create an instance, appropriate instance of an outgoing invoice. Okay, we have to generate an invoice number, and that's why we just took advantage of dependency injection, declaring a dependency on an invoice number generator. And let's pretend to not having seen this very line of code. We'll talk about this line later, okay? Just a couple of minutes later. And sooner or later, the application is going to try to associate our invoice to a job order, and that's when the Mediator is going to call our Saga in order to have it aware of what the application did request, as just requested, and we're just going to fetch the invoice instance to execute some business logic. I think you'll end up downloading map source codes, and you're going to have a look at it, and you're going to have a look at an implementation of a simple domain model. Okay, being a domain model is the very reason because of we have business logic implemented as methods on our entities. Okay, but that's not something you're forced to do in order to implement CQRS. Okay, that's just something I'm used to, and so that's the very reason I defined a domain model for my sample application, and then we're going to have the modified, the altered job order, in this case, save it back to the database. Okay. The point in Sagas is that we're not going to trying to get rid of the need of a human or a scheduling engine in order to fire our codes and to notify the customer about an expired invoice. So that's why we have this line, okay? And this line refers to one of the advanced bus features I was talking about a couple of minutes earlier. This is where I'm asking the bus, okay, actually by a method supported by our base class. I'm just asking the bus to be notified about an invoice expiration, okay? So I'm going to ask the bus, so please tell me at this point in time that that's what happened, okay? And it's up to the boss to get back to me later in time, tell me, okay, you have an expired invoice, and that's the structure of the message. That's why I can implement a method. I've named it timeout, but I could have used a different name. The point is that what I'm allowed to do now is to just use this message in order to fetch the invoice instance, okay, verify whether it's now paid or not, and should it be paid, I could mark it as being expired, and then notify my customer about the occurred expiration and save the object back to the database. Okay, now what we ended up having is pretending to be workflow manager that is very near, speaking a language that is very near the business language, because I am the workflow manager that is going to manage outgoing invoices. And I, as a workflow, I am going to start every time an application throws an issue invoice command to the Mediator, to the bus. And I'm also going to be activated every time the application tries to associate an invoice to a job order. All these messages, commands, messages, stores a data structure that allows a single handle method implementation to use the data provided by the message in order to perform a specific task that is pertaining to our workflow. So, invoice issuing, invoice association to a job order, and I'm very sorry, this is something that shouldn't have been here. I'm very sorry. Okay, less code, more readable. And then our last message, which is that is an invoice expire message in order to manage invoice expiration and then customer notification. And we could manage the need to start collection, credit collection process, implemented in the very same way. Okay, so having different timeouts, telling us that either the invoice is expired or it has expired and has not been paid after a specified amount of time after expiration, and so on. Okay, I think we made it to get to the end of our webinar. Just a couple of resources. This is not going to be kind of an advertisement. Just trying to point you once more to the source code you can take advantage of in order to further have a look at CQRS implementation. Actually, MERP implements both CQRS and event sourcing. Should you need some more explanation about the code, this application is the one I wrote as a companion project for the book I wrote along with Dino for Microsoft Press. And that's it. I think it's now up to Mauro and Sean to talk why N-Service Bus is going to prove to be very effective as your bus of choice in order to implement CQRS and Sagas.
So thank you, Andrea, for the entire webinar. And let me, before moving on and sharing some code that is strictly related to how in-service bus work in this space, I'll try to answer some questions that came along. And one is from Christian, that is, can you tell me more about the normalizers? I'll try to briefly answer the question, even if I think that we are going to have another webinar, well, a series of webinars, to be honest, diving into all the details that we introduce today. So there will be a series of webinars diving into all the specific details of what we introduced today. So the normalizers are basically a way to react to events when in a pub sub world, where we have a component that is handling an incoming event and saying, well, the user interface or a specific scenario that we want to implement expect the data that needs to be shown to be in a specific frame, to be shaped in a specific way. That is not the one we are storing data in order to store the aggregate itself. So from the CQRS perspective, what we have is one channel that is the one related to writing data, and we have one single source of truth in order to write something. That is the aggregate we are writing to, using the write channel. And when we read, we can have multiple read channels, meaning that we can have different shape of data written to satisfy to satisfy different read scenarios or different application requirements. If we decide to use a mediator or a bus in order to handle the pub sub system, what we end up having is that read models will be denormalized read models in an eventually consistent manner. And what we can do is subscribe to events published by the domain model and then generate a denormalized view of the write model itself in order to satisfy a specific read scenario. But I think that the topic itself is large enough to deserve a specific webinar for it, so I'll take note of it. And then there's a Chris asking, the issue invoice command class inherits from the command class, or perhaps class is an interface, but it doesn't follow the naming convention for interface it is. What is the namespace of that command class? In other words, where does that command class come from? Basically, in the implementation that Andrea shown, if I recall correctly, is not using n-service bus specifically. It's a self-built bus in-memory thing. And
correct.
Thank you. And is using this command-based class in order to satisfy some technical requirements. And as we've shown in previous webinars, when we go down to the root using n-service bus, you're not really required to implement any interface. We have an iCommand interface, or we support plain old CLR objects. So you can have a command class or an event interface not inheriting from any other base class at all. So before concluding the webinar, let me show how the demo behaves when run on your local machine. Pressing Ctrl F5 will cause the solution to be built and will be started. What's going to start are 3 different console applications and a web app. The web app basically represents a very simple online store allowing to buy videos and different educational material, and the console apps represent the backend things. So the Saga is built in order to allow you to cancel your order if you want to cancel it within 20 seconds, meaning that you have this buyer remorse thing that allows you to cancel your order within 20 seconds. So we can tick a couple of things and place the order. And as you can see, the order has been placed. So the command has been sent by the web application to the backend. The Saga started processing an order. An event has been raised so that the web API application and the front end can react, adding that order to the list of things. And within 10 seconds, we haven't canceled the order, so the order has been accepted and moved from the ordered thing to the received one and marked as completed. If we tick some more, we can place another order, and then now we can cancel the order, and it's canceled because the buyer remorse period is not exhausted yet. So what is happening is that basically the submit order comes in, the data are stored in the Saga itself, and as we saw, the request timeout is called. So whenever the buyer remorse fires and the Saga is still there, the order is automatically accepted within 20 seconds. Otherwise, if the user hits cancel, then the order is canceled, the Saga is marked as completed, and the buyer remorse timeout is then discarded. These two events are then handled by a couple of other endpoints in the solution. So what we have is the content management system and the customer relations endpoints. Both these react to the Saga stating that something has happened, such as order accepted or order cancelled, and react basically doing nothing, just printing something on their own console apps, but shows how you can integrate in your business process some other external services that need to deal with the fact that something has happened to an order.